Hello everybody. In this video, we are going to talk about TCP connection management. So we know that TCP is a connection-oriented protocol, and hence it requires that you have a connection establishment procedure and a connection release procedure. So let's see how TCP handles connection management. So first of all, we have the connection establishment process. So as we had discussed in the general transport layer connection establishment, TCP connection establishment takes place through the three-way handshaking procedure. So we have at the first we have the host one, the first and the one who is initiating the connection will send a segment with the sync bit set to 1. You can recall the sync bit is there in the header, so it will be sent to 1, and it will start with an initial sequence number X. So this segment is sent to the host 2, and host 2, when it receives this packet or this segment, then it sends an acknowledgement, and also it sends its own sync. So this was first was a sync message which was sent, then there was a sync. Let me write it here. So sync was sent by host 1. This was received at host 2, and host 2 sent an acknowledgement along with the connection accept. So in this segment that is sent by host 2, the two bits will be set to 1, that is the sync bit and the acknowledgement bit. And here you can see the acknowledgement number field will have X plus 1. Okay, why X plus 1? That is because here the sync segment is 1 byte. It is 1 byte. So the next byte expected, that is what is being sent. So next byte expected is 1 byte. So the next acknowledgement number is X plus 1. And when this is received by the host 1, okay, it sends its own acknowledgement of the connection accept. So it sends this. So it sends, that is the sequence number, that is the next byte, X plus 1, and acknowledgement, because here this also has it is also a sync packet, so that is also 1 byte. So this is 1 byte, this is 1 byte, so both are 1 byte. So the next byte expected is Y plus 1. So this is sent to the host 2. So this is how your connection establishment takes place. Now there can be some issues with this problem here, or with this connection establishment procedure here. Okay, and of course you have the things like timers and all to take care of review of to consider the retransmission. So now what is the issue that is here? We can have something called a sync flood. So what is a sync flood? So here you can see the host that wants to establish a connection will send a sync. Okay, the host 2, now if this host 1 is malicious, if this host 1 is malicious, that means it just wants to disrupt host 2. So what it will do is it will keep on sending sync messages one after the other, and it will not every time a sync message is received by host 2, it will send the acknowledgement, it will send acknowledgements, Now host 1, what it will do, it will not send back anymore, it will not send back anything. So it is like just saying hi, and then somebody pressing your calling bell and then running away, and every time host 2 has to go and open the door. Okay, so here the problem is much more than just opening the door. Okay, because you have this host 2 will have to, every time it sends back let me just clear these so every time this host 2 will send the acknowledgement, so sync plus acknowledgement, okay, it has to remember what is the sequence number it had used. It has used Y. So this is for another one, sync plus, say, another acknowledgement, So here it says, say it uses P. So it has to remember all of these sequence numbers. So this kind of an attack, you can think of it as an attack. This is known as a sync flood. Okay, so how will the transport layer handle this, TCP handle this? So it will use something called sync cookies. Okay, so what is a sync cookie? So you will have something like you have a function. You have a function. To this function, you will give, say, the destination address. So there is a sync which arrives. So when this sync arrives, that at this point the host will call this function. So whatever destination address is given here, okay, it will be put here. Then there will be a secret. Now what is the secret? The secret is the value which only host 2 knows. Host 2 will only know this secret. So it uses the secret, and what this function will give me? It will give me a sequence number. It will give me a sequence number. So when it replies, it uses this sequence number. So it does not have to remember. Okay, now if there is a reply, in case there is a reply, okay, if there is no reply, then forget about it. You're not saving anything. Okay, but if it receives a reply, then this acknowledgement will have say the value that was sequence number that was generated here was x. Okay, so x was given. So when this acknowledgement will come back, it will come back with x plus 1. Okay, so what the host here will do is that it will call this function again, okay, with the destination address, and the secret remains the same. Both are same. So destination address is also same, secret is also same. So it should get x. So it will now match this x plus 1 with this x plus 1. If it is same, if both are equal, that means problem is solved. Okay, that means it is this connection. So it does not have to remember this anymore. So this is known as your sync cookies. Okay, so it generates a sequence number cryptographically using the destination address and some local secret. So in this way it can avoid this sync flood. Now next we have connection release. Okay, so when the connection, once the connection is established, after that we will have, after the three-way handshake, the data transfer will take place. And once data transfer is over, okay, then any of the two parties, communicating parties, can initiate the connection release. So what we have is something like this. First, the initiating party, let's say host 1, will send a segment with the fin flag set to 1, indicating that it has no more data to send. So let me just draw it here. So I have host 1 and host, and very sorry for this. Let me just clear it all here. Okay, let me just draw and show it here. I'll give you the slides later. So here I have host. This is host 1. So I will send a segment with fin bit set to 1. Okay, when this receives this, it sends an acknowledgement. So after this, host 1, at this point from now on, host 1 will not be able to will not send any data anymore. So this side connect, that is transfer from host 1 to host 2, will be over. But if it is since TCP is a full duplex communication, so data can flow from host 2 to host 1. So if host 2 wants to stop, then host 2 will send its own fin, okay, and host 1 will have to acknowledge it. Okay, now data from this side will also stop, and then the connection will be released. So that is about your connection release. And now in connection release, we had the problem of the called the two army problem. So in the two army problem, uh, here you may think that one will disconnect, other will not disconnect. So this can be avoided by, after receiving the acknowledgement, they will wait for 2 maximum packet lifetimes. Timers will be used. Will use timers, and it will wait for 2 maximum packet lifetimes. So if within this time the acknowledgement is not reached, then say this is lost, then after waiting for 2 maximum packet lifetimes, it will disconnect. It will assume that this side connection is, this side data flow will stop. Okay, so this will help you avoid the two army problem. Now this whole process can be explained with the help of a finite diagram, finite state diagram, like this. So initially both the server and the client, now we are talking about client and server, it can be just host 1 and host 2 also. So I'm assuming that one side is sending the request, the other side is receiving the request. So initially both are in the closed state. Closed state means there is no currently active or any pending request, connection requests. Okay, so let us go from the client side. So here in this diagram, the dashed line is for the server and the solid lines is for the client. Okay, so the client, you can see here, performs a connect. Okay, so you can see the notation here. You can see it is something like this: x/y. Okay, so x, here you can see connect/sync. So what this means, it means that this is some event which occurs, okay, something that is done by one of the parties, and y is what is sent, what information is sent. Okay, what happens, what is the action taken. So this is an event, x is the event and y is the action. So the events, what can be the events? Events can be the client or server using the connect function call, or doing something like listen, or maybe sending the sync or sending the finish. So, or receiving a finish or receiving a send. So you have this, and then what happens as a result of this event occurring, the entity, which is either the client or the server, will perform some action. So that's y represents the action. So this action can be sending a segment like sync, sending sync, or sending finish, or sending acknowledgement. Okay, or it may be not doing anything. Okay, like here you see. So the action here, it means that acknowledgement is received, event, and nothing is done. It just moves from one state to another state. Okay, so let's start from the client side first. So the green line will show the client side. So client side, it executes the connect function call. So connect function call means active. It is actively trying to establish a connection. Okay, so it sends it is initially in the close. So after executing the connect, it will go to the sync sent state. So these are the states. So it will go to the sync sent state. And what will it send? It will send the sync segment. So something like this. So initially it was in the closed state, then it has sent the sync. Okay, and after sending the sync, it goes to the sync sent state. Okay, so it is here. Now what it will do, it is waiting. What happens now, at this point, it is the work of the client, so this of the server to send the acknowledgement. So it is waiting. So at this point the client is waiting. So when will it be active again? When it receives the sync plus act from the server. So when it receives this, you can see when it receives the sync uh, from the sync plus act from the server, it goes to the established state. So it goes to the, now this is established. At this point connection is established. Connection is established, and what happens? It sends back the sorry, not the sync, it sends the acknowledgement. Okay, so you can see it receives sync plus ack and sends the acknowledgement. So now it is in the established state. Now data transfer can take place. I'm only talking about the client side, so I'm only looking at this now. Now let's say data transfer takes place, all this data transfer is happening. Now it wants to stop the connection, it wants to close the connection. So what it will do, it will issue a close primitive, or it will call the close function. So the close function will be called, and it will send the fin segment. So close, it will call close. Okay, it is in established, then it has called the close function, and it has sent the fin segment. Okay, so after doing this, which state will it go to? It goes to a state called the fin wait 1. Okay, so it goes to the state fin wait 1. All right, it is not closing the connection immediately. Okay, after fin back 1, when it receives an acknowledgement, okay, you can see it receives an acknowledgement from the server, then it goes to the fin wait 2. So it receives an acknowledgement. So when it receives an acknowledgement, it goes to fin wait 2. Now does it send anything? No, its work is done from this side. Now from this side data transfer is done, but still it is not closed. Why? Because there might still be some old segments around in the network. So it will wait for some time, for 2 maximum packet lifetimes. It will wait to see if there are any more data which is floating around. So it will wait for that. So you can see it is going to, it goes to this time wait. So when it receives a fin from the other side, now it receives a fin from the other side, and it sends an acknowledgement of its own. Okay, so what happens now? It goes to this timed wait. Okay, and when it goes to the time wait, when the timeout occurs, then only it goes to the close state. I made a mistake here. I should have said that first it is waiting for, in order to release the connection, it cannot close it because the other side is still sending. So in fin wait 2, it is waiting for receiving a fin segment from host 2. This is host 1 and this is host 2. So it is waiting for a finish to receive from the host 2. So when it receives the finish for host 2 and sends an acknowledgement, okay, it still, after that it waits for 2 maximum packet lifetime, and then it goes to the closed. So this is your from the client side. Now let us go to the server side. Server side also initially it is in the closed state. So what happens now? If it wants to receive connection, it will execute the listen function. It will execute listen and wait, and it will not send anything. So it is listening. All right. Now when it is listening, it goes to the listen state. All right. So again, let me draw here. Now we are looking at host 1 and host 2. So we are looking at host 2 side now. Okay. So it executes the listen function, and it is in the listen state. Okay. So it is waiting to receive connections. Now what can happen? What event can happen? It can receive a sync from some host. So when it receives a sync from some host, you can see when it receives a sync from a host, okay, it sends a sync plus acknowledgement. It sends a sync plus acknowledgement, okay, and then it moves to which state? Sorry, it moves to sync received state. So it is now in the sync RCVD, sync received state, after sending this. So now what it has to do, it has to wait for the acknowledgement. Now it is waiting for the acknowledgement. So when it receives the acknowledgement, it goes to the, see, you can see it receives the acknowledgement. So it goes to the, it receives acknowledgement, then it goes to the established state. So once it's in the established state, after that data transfer, same, now data transfer takes place, okay, and after data transfer, what it can do, it receives a fin, okay, it receives a fin from the it receives a fin from host 1, okay. So how will it react? It will send an acknowledgement. It should send an acknowledgement. So it sends an acknowledgement and it goes into the state. It goes into the state close wait. So it goes into the state, sorry, close wait. Okay, and then, so that means now this from this side no more data can be sent. All right, but it is still waiting because it can send data, okay. Now when will it stop sending data? When it executes the close function call. So when it executes the close function call, okay, it executes the close function call, what it will do, it will send a fin. It will send a fin, and what it will do, it will wait for the acknowledgement. So it goes to the last acknowledgement state. So it goes to the last ACK, and then let's say here it receives the acknowledgement, and once it receives the acknowledgement, now it is in the close state. Now it is in the close state. So this is how your the basic principles of your connection establishment and connection release in TCP works. Now you may see in the diagram, you may see some other lines. Okay, so these are also from the client and the server, but mostly from the client. Okay, so this is if both are trying to send at the same time, so simultaneous open and so on. So so that is all in TCP connection establishment.